Hi, I'm Bryson Schultz, and I'd like to show you guys here over at Trek some cool prototypes that I came up with in order to have a new bike fit for your specific needs that you would like. So, the things that you mentioned that you needed were that the bike has to be light, durable, it has to be strong, and under $200. And so, in order to do that, we figured out that the different properties of the thing had to be that since it's light, it has to have low density, it's durable, so it has to have a high tensile strength, and also it has to be strong, so it has to have a high level of hardness to keep the bike together so that if you're on any type of terrain, you're not going to fall off or it's not going to break on you. So the materials that we used to make this bike were metals, polymer, wood, and ceramic. And so for metals, we have to use this because the bike has to be sturdy, and also there are metals that are lightweight and it'll keep the bike together. Also, polymer because it's soft and elastic, and then wood because it has a low tensile strength, and finally the ceramic because it can mold onto the bike and keep it together and also make it look cool when you're riding because that's important as well. So I'm going to go over the different things more in depth and show how they relate back to the things that you said that you want your bike to have on it and have to do with it right now. So the metals, it has to have a high melting point to avoid the bike melting in intense heat because we don't know where your clients are going to be riding, and so we want to make sure that it's geared towards any types of terrain or any types of weather that could occur. Also, high tensile strength to make it durable, high density so it won't fall apart, so a medium hardness to make it strong, and variable malleability to make it flexible so you can go over any type of terrain and it will be a smooth ride while going. So the polymer is soft, it ranges in tensile strength, it has a low elasticity, and this is for inside of the bike and all around the bike. Also, low boiling point and a low density. And then the wood fibers, part of the bike as well, would have low tensile strength to make it strong and keep the bike together, have low elasticity as well to make it hard. And then ceramic, which is very hard, and this is to like mold onto the bike and have the bike create its shape and be together. Most ceramic is like you see ceramic bowls and everything, and so our bike would have ceramic on it too in order to have the bike have its shape. And so then high tensile strength to make it durable, ranging elasticity so it can stretch to form onto the bike and make the bike work better. Also has a high melting point, so if the bike's if it's hot or your bike's under intense heat, it's not going to melt, and then a high density as well. So we chose beryllium oxide because we felt like that was the best possible metal and everything that incorporated everything that you wanted for your bike. So it has a low density, which is light. It has high hardness, which means it's sturdy and strong, and a high tensile strength, which is durable, which are all the things that you requested when we talked about making the bike. And so how the model is going to be, this is how our material model is. So in the green you see here, the green are the metal ions, and then the pink negative signs are the free electrons, and then they're all connected together by these purple arrows that bring the bike together. So the metal ions need to conduct the free electrons in order to keep the thing circulating and keep the bike intact so that when you're riding, you're not going to fall off and have it break on you and all that. So this material model is really key because it has all of the metal ions spread in equal rows and everything so that they will keep intact and stay together for the bike. So I'd just like to thank you all, and I hope you choose our bikes for your next Trek model. Thank you very much.